Hey guys, go ahead and get out your note sheet for box and whisker plots. So you should have looked at box and whisker plots a little bit in pre-algebra, but if not, here's what they are. It's a visual way to display the distribution of statistical data by displaying the range of the data and showing how the data is separated into 4 equal sections called quartiles. So if you kind of remember seeing these maybe last year, it's going to end up looking something like this. And we'll take a look at those in a second and what they are, but it's really just a way of showing data. So what we're going to be looking at is the 5-number summary, and it's another name for the visual representation of a box and whisker plot, and it refers to the 5 pieces of information that can be found when you're viewing a box and whisker plot. So again, if I have my box and whiskers, and this is very bad drawing, but there's 5 pieces of information, something here, something here, something here, here, and here. So that's the 5-number summary. So here's what your 5-number summary consists of. It has a minimum, and that's also called a lower extreme. You might want to add that on your note sheet, and that refers to your smallest number in the data. We have quartile 1 or lower quartile, and that's going to divide the lower half of the data into 2 equal parts. So it's that one spot where it's splitting the lower set of data into 2 equal parts, or 2 equal halves, we can even call it. Your quartile 2 is also your median, and this is where you're going to divide all of your data in half. A median represents the middle number in a data set. And then quartile 3 is the upper quartile, and that's where it divides the upper half of data into 2 equal parts. So your 3 quartiles, 1, 2, and 3, are really just finding middles of your data. The main middle is quartile 2, and then you take everything below it and find the middle. That'd be quartile 1. Everything above your median, you'd cut that in half, and that's quartile 3. And then we end with our maximum, which is also referred to as your upper extreme or the largest number in the data. Some other vocabulary that you'll hear when we talk about statistics and box and whisker plots is range, and range is the same as you've learned about it before with statistics. Not range as in the y values like we've been doing earlier this year, but range for statistics is the distance from the highest to the lowest value. And the way you calculate your range is by subtracting. It's the maximum minus the minimum gives you the range. I would probably include that on your note sheet so you have your way of finding your range when we need it. So we also have this inner quartile range, and really the words kind of break apart what it means. But if you're in inner quartile range, you are the distance from quartile 1 to quartile 3. And it represents that middle 50% of the data. So basically it's just the range of the quartiles. We don't care about the max and the minimum. It's just taking quartile 1 and quartile 3 and subtracting those to find the range of just that middle part of data. And I don't know even how this happened, but please fix your note sheet to have interquartile spelled the way you see it on here, not the way I had it on your note sheet. I apologize about that. It's one word, interquartile, not interquartile. And then the last thing we're going to talk about throughout our statistics unit is an outlier. And an outlier is a value that's much greater or much less than the rest of the data. It's pretty obvious usually when you have an outlier, but you'll learn a little bit more about how you can specifically find one, but it's at least 1.5 greater or less than the interquartile range, meaning 1.5 standard deviations, which we haven't talked about yet, but basically if you have a bunch of numbers like 4, 5, 6, 7, 8, 9, 10, and then you have the number 100, 100's an outlier just because it's really far away from the rest of the data that you had. Outliers affect data in different ways. With a box and whisker plot, it would really just make the box and whisker plot look longer than it really should be for the rest of the data that you have. Okay, so next thing we're going to do is label the box and whisker plot and then answer some questions about a basic box and whisker plot. So we'll start at the far left. This is your lower extreme, or you can actually refer to it just as minimum. Making our way over, so you've got this box part of your box and whisker, so there's 3 lines if you really look closely at it. Those are all of your quartiles. So we start with the smaller or lower quartile. I always just refer to it as Q1 or quartile 1. Your median right in the middle is where it's cutting your data in half. That's also quartile 2. And then your upper extreme is quartile 3. And then we make our way all the way to the furthest to the right, and that would be your maximum. So I would actually put both labels on there so that you can refer to the definitions in your notes, but then shortened versions that you can use from now on could be minimum, Q1, Q2, Q3, and maximum. So again, a box and whisker is really just a way of showing you the split of data. So we know a median's cutting all of your data in half. So if you look where this median is, basically saying half the data is on the right, half of it's on the left. And then if you take everything that's on the left of the median, this quartile 1 is cutting all of those numbers in half, or finding the middle of those. And then our quartile 3 is taking the upper half of the data that's above the median and finding the middle of that. So what we've created is 4 equal sections, and if you have data and you've created 4 equal sections, then each of those sections is going to represent 25% of your data. So if you also want to include on your box and whisker plot that each part here, so the whisker, the left side of the box, the right side of the box, and then the bigger whisker are all 25% of your data. So with that said, the box in the middle represents the middle 50% of your data. And then the length of each section, they're normally never the same length. That'd be like a perfect example if it was. The length of each section is really just showing you how spread apart the data would be in that grouping. So the lowest 25% of data, we're basically saying, well, how far apart were those numbers that made up that lower 25%? And the bigger the section, it's saying the further the numbers were spread apart. So these are your steps for constructing a box and whisker plot if you have to do it by hand. We're not going to do a whole lot of these since you really won't have to, but we will take a look at how it works so you understand the process. So step 1 would be to list your numbers from least to greatest. Once you have that done, you're going to find your middle. So the reason why we need least to greatest is because we need that true middle, which can be found when they're in order. So find your median. Step 3 would be then to, once you have your median, find your lower quartile. So take the numbers below your median and find the middle of those. And then take all your numbers that were above your median and find the middle of those. So that's finding quartile 1 and 3 at that point. Step 4, obviously look at your max and min. You don't really have to find them. It should just be the number furthest to the left and furthest to the right. And then step 5 is how we're going to draw it. So on a number line, you would draw a vertical line at your median, your lower quartile and upper quartile. And then we connect those, which are going to end up making the box of the box and whisker. So it would end up being something like this if these were your quartiles. And then step 6 would be to draw your whiskers, which become horizontal lines that extend from the outsides of the box down to the minimum and the maximum. So they would end up being something like that. Again, this really would depend on the data you have to show how big each of the sections are, but what we're doing is basically finding a middle, finding a middle, finding a middle, extending out to the max and min. Your calculator steps are probably going to be our go-to for the majority of these when we do them in class. So these are the steps. We'll do some more of this whenever I see you guys in class next time, and we'll practice this way. But everything's in the stat section of the calculator. It's just you get your data a little bit different, so we'll just hang on to this until I see you guys again. So we've got this example here, and we're going to basically answer a whole bunch of questions about it, just analyzing this box and whisker plot. So it's already created. We just don't have the data that made it, but we can tell a lot of information about this box and whisker plot without even seeing the numbers that originally made this. So first thing is we're going to look and locate that 5-number summary, and that's just the 5 different pieces of information you can see on the graph. So the one we labeled on your notes would help out with this. So if we need the minimum, it's just the lowest number that you see, and I know my minimum here is 16. My quartile 1 is that first part of the box that I have, and that's right here at 18. Quartile 2 is the same as your median, and that's at 22. Quartile 3 is the last part of the box, that's at 26. And then your maximum's the biggest number, which is at 28. So all of that can be found without even knowing what numbers actually made this box and whisker. You could still tell that information. Also, we can do our range and our interquartile range without seeing the data that we had by just seeing the box and whisker. So we know range is the distance from the max to the min. So we're going to do our maximum value, which is 28, minus our minimum, 16. And that's going to tell you how far apart all of this data is, and we should end up with 12. And then your interquartile range, it's still a range, but it's only the range from quartile 1 to quartile 3. So if quartile 3 was 26 and quartile 1 was 18, then we're going to subtract 26 from 18, and we should get 8 for our interquartile range. These are some of the kind of questions you can expect to see about Box and Whiskers, is seeing them and analyzing where different pieces of data are. As long as you know how to identify those, you should be able to easily answer these questions. The other kind of questions you're going to see from Box and Whisker plots actually refer to what I call an even-odd breakdown sort of situation. And it's, again, seeing a box and whisker without seeing the data that created it, but then also being able to analyze and tell exactly how much of that data was within each of these sections. So we've got two examples here so you can kind of see how this would work. The first one says, if the data above represents 12 different ages, and no one is the same age, and that's important, which means you don't have multiple people that are 22 or 16, so everyone's a different age. We want to know exactly how many people are less than 18 years old. So, and then how many people are 22 or older, and how many people are greater than or equal to 18 but less than or equal to 26, basically within that box range. So the way you would need to do this is starting with 12. You really need to understand how, if you had 12 numbers, how it would break down when you would go to find a median. So there's different ways you can do this. One of the ways you can do it if you don't have too much data is you can actually make a symbol to represent the different amounts. So if we had 12 different ages, you can just draw 12 of some kind of symbol. I did X's, and then you can pretend like you're finding the median to see, you know, what kind of situation is going to happen when you find the median. So you find a median by finding the exact middle, and here, because we're finding the middle of 12, we actually end up with an exact middle that happens to be right in between two of these X's. And again, these would normally be numbers, we just don't know them. So what that means is when we did the median up here, if this was 12, that you're actually going to have a median in between two numbers, which means there's no people or no ages that represent that true median. It was just an in-between average of two numbers. So that leaves 6 people that are below the median and 6 people that are above. So now we've got to do our quartiles. So when we go to do quartile 1, we're going to take all of this numbers, or all of this data that was below the median, which are those 6 values, and we've got to cut that in half. So when we go to cut 6 in half and find the middle, again, it's going to end up being another middle that's right in between two values. So that's going to state at that point that you've got 3 ages that are in this part of the box, 3 that would have been the whisker, and then when you go to do your upper quartile, it's going to reflect what your lower quartile did. You have 3 as your upper quartile, and then 3 from your upper quartile to your maximum. If you add it up, 3 plus 3 plus 3 plus 3 is where the 12 comes from. And realistically, that kind of split comes from understanding that when you have even amounts of data, you're always going to have a middle that's in between. So there's never going to be a specific person that represents the median or the quartile 1 or quartile 3 if we're breaking apart even numbers. So now when we go to answer the question exactly how many people are less than 18, you would look at your box and whisker, look at where 18 is, and look at the people that are less than. That's going to represent 3 people. Exactly how many people are 22 or older. So if you include 22, well, we just said there's no one that's actually 22 because that was a middle that was in between two numbers. So there's no one there, but then if we look at everybody above 22, that's 3 plus 3, which is going to give you 6 people. And then exactly how many people are greater than or equal to 18. But less than or equal to 26. So that includes quartile 1 and quartile 3 and everything in between. But again, we've got a 0 at quartile 1 and 3, so that's only going to be the 6 people within that box area there. So that would answer this. We're going to change the scenario just a bit on the example 2 so you can see what changes whenever you have even versus odd numbers. So let's look at example 2. So this time around, it's the same situation. All we're doing is changing the number. So this time we're working with 11 ages instead of 12. So if we wanted to imagine what it would look like with 11, again, because 11 is not a big number, you can use a symbol. So I drew 11 little X's. And so I'm going to do the same process as before where I'm going to look for my median if I had 11 pieces of data. So median would be canceling your largest and smallest until you get to a middle. And this time what's going to happen is you're going to cancel 5 of the X's on each side. And what you should find out is that your middle is actually represented by that 1 X that's right there. So what that would mean if there was 11 ages here, when we go to find our median is exactly 1 person. So that does make a difference from last time. Last time we had 0 people represented at the median. This means there's one person that's actually 22 right now. So we've got 5 people that are older than 22, 5 people that are younger than 22. So now our goal for our quartile 1 and quartile 3 is to take these remaining 5 people and to find the medians of those, or the middles of those. So quartile 1, if you take those 5 ages and you go to find the middle of those 5, and again, what's going to happen when you go to find the middle of 5, you're going to have that dead-on person in the middle, and then you're going to be left with 2 on each side. So that'll happen for quartile 1 and for quartile 3, which leaves you with 2 on each side. So if we had to fill this in, we know there was 1 exact person as a median, there's 1 exact person that's quartile 1, there's 1 person exactly at quartile 3, and then that leaves 2 below quartile 1, 2 above quartile 1, 2 below quartile 3, and 2 above quartile 3. So if you added these up, you've got 2 plus 2 plus 2 plus 2, which is 8, plus those 3 people that are the dead-ons at your median in quartile 1 and 3, that makes your 11. So it's going to change the way you answer these questions below because of that 1 person that's represented at your middles. So for letter A, exactly how many people are less than 18 years old? Less than 18 does not include that 1 person that's 18, so this time our answer is going to be 2. B, exactly how many people are 22 or older? So 22 includes that 1 person that's at that median, plus everybody above it. So there's 5 people above it plus that person there. That makes 6. So that's actually the same as the last answer. And then letter C, how many people are 18 all the way up to 26, including 18 and 26. So we've got the 1 person that's 18, and then the 2 in the box, plus the 1 person that's the median, the 2 in the upper half of the box, plus the other 1 person there. So we've got 7 people, which does change that answer a bit from before. So hopefully you kind of see the difference of even and odd breakdown whenever we're trying to find middles. So the key to really understanding how to answer those kinds of questions with finding the amount of people or numbers within each section without having your data would be understanding your even and odd. So here's kind of a conclusion that we can come up with that'll help you to answer these questions. So when you're finding the middle of an even amount, the middle is always in between 2 numbers. So if you're looking for the middle of 24, you're going to cut 24 in half and you're going to be left with exactly 12 on each side. And then when finding the middle of an odd amount, the middle is exactly 1 number, so you have to take that 1 number out because if they're the middle, they don't count, and then what's going to be left over on each side would be the split from there. So if we find the middle of 23, there's 1 person in the middle, so you take them out, which leaves 22, which is going to be 2 groups of 11 on each side. So that's always how it's going to work with even and odd. So that's it. We'll take a look and practice some more with Box and Whisker when I see you guys next class.